I'm going to present my final project on the AI course. And I got this data set where we have all these 4 different features. And what I'm trying to predict is the electrical output. So since we have numeric values trying to predict another numeric variable, I decided to do a regression for this model. The first step I had to take was to split the data set into 2 different groups, 20% for testing and 80% for training. I'm using Excel for this exercise because it was very short, very small data set. So I decided to use it. And I assigned random numbers for each individual row. I sorted it by in ascending order and then just separated 20% of my data set for testing and then 80% for training. And then I did another breakdown in my my training data set where I got 75% of that for training and 25% for validation. So with my training data set, I decided to test the 4 features that I have. And I also tried them squared just so I could have like different values for my regressions and try different models. Maybe this is not a linear regression, so the square values will tell me that. And then, of course, I'm trying to predict the electrical output. The first step I took was running individual or single regressions for each individual feature because I wanted to see what was the R squared and if the p-value was below 0.05. That was the case. Yes, p-value was low, but I saw that for ambient pressure and the vacuum, R squared was stronger than for the other 2 features. Just something I kept in mind. And for my first model, I tried 4 different models for this exercise. The first one, I just tried a multiple regression using all 4 features. And I got a very good result, very strong R squared, p-values significant. The second model I tried was using all 4 features plus their squared values as well. And I also got a very significant R squared. And one thing I noticed in this model was that the relative humidity and the vacuum squared, they had higher p-values than 0.05. So just something I kept in mind. And then I ran ahead and tried a third model by excluding these 2 features. So I ran a model without these 2 features. I got a slightly better R squared where all features had a significant p-value. And the final model I tried was just with 2 features as a multiple regression using only the most significant features when I look at the R squared, so ambient pressure and the vacuum. So that was my 4th model. Then I ran these numbers on my validation set, and these are the numbers I got by using the formula with the results from the intercept as the initial value and the coefficient. So I applied that formula into my validation set for each individual model. These are the results I got for each individual reading. And then I subtracted, got the absolute value from the actual result and got the mean out of that. So I'm decided to use the mean absolute error for measuring the performance of each individual model because it has a strong interpretability. So it's easier for me to explain that for this reading, for example, my model was 4 megawatts off of the actual value. And the results I got is that model 2 and 3 were very close together, but model 3 got better averages for all the errors, the absolute errors I got. And finally, I went back to my test set and ran that model. And this is the mean absolute error I got. So slightly higher than what I got from my validation subset, but this is the model I decided to use. And these are the results I got. And again, I decided to use the mean absolute error to measure this because this gives me a number that's very easy to interpret, meaning that my model is usually off by 3.5 megawatts.